All right, here we go. So our exponential function is in the form of y equals a times b to the x. Do we see that? Okay, that's our exponential. Y equals a times b to the x. Okay, and what it does is it generates consecutive y values that have a common ratio. So now we're on to a common ratio. Got it? Okay, and then we're going to relate the functions and tables. How do they relate to the common ratio? Okay, so we're going to be talking about. So notice here that this exponential, it's an exponential because x is the exponent. Remember that? Exponential means that x is the exponent, okay? So if I have this value here, y equals 7 times 3, this function here, y equals 7 times 3 to the x, and I'm given x values, all I'm doing is plugging in for y to get my value. Make sense? So I'm plugging in 0. One thing we need to remember is the 0 rule. Anything to the 0 power equals what? 1. Anything to the 0 power is 1. Okay? So we're going to fill in our table. So on our table, we're plugging in 0. What is 3 to the 0? 1. And what's 1 times 7? 7. So that's our first y. Are you with me? The 3 is the equation. It's in the function. It's right there. Okay, so we have 1. Now we're going to plug in 1 for x, right? So we're saying we have 3 to the 1. Anything to the 1 power is its self, right? So 3 to the 1 is 3. What is 3 times 7? 21. Are you with me? Okay, now we're going to do 2. 3 squared is what? 9. What's 9 times 7? 63. Okay, 3 to the 3rd. 27, and what's 27 times 7? There we go, 189. I'm letting everyone come to the same conclusion. I wanted them to think about it themselves, okay? Now we're going to do 3 to the 4. All right, 3 to the 4 times 7. What'd y'all get? 567. Okay, so do we all understand how we got our y values? Yes. Yes? Anyone's like, I don't know where they came from. We're substituting in the x's. Yeah. Yes, we're just substituting for x. We follow PEMDAS. So we follow PEMDAS, which is exponents then multiply, right? Exponents then multiply. All right, now to find our common ratio, your common ratio is going to be y2 divided by y1. Okay, a ratio means you're working with some type of fraction, right? So in order to find our common ratio, it's our y2 divided by our y1. And y2 just means what happened next, right? So right here, common ratio, 21 divided by 7. 3, right? 63 divided by 21.
3.
189 divided by 63.
3.
What? 567 divided by 189. 3. Oh my gosh, there's a common ratio. It's an exponential. Well, we knew that, but
Wait, so if that's good,
we're learning if the function's not there, how to find the common ratio.
Oh.
No, linear is adding or subtracting the same amount. That's a common difference, right? Okay, we're on a common ratio, which means we are dividing, right? And it's exponential. Okay, so I'm going to give you 2 minutes for you to do 8. Is that cool? So you're going to fill in table 8 and verify the common ratio. All right, let's check your work. Hopefully you took the initiative and also tried 9, your finger at 9. So, what were your Y values for 8? 32, 48, 72. And then what was your common difference? 1.5. So it makes sense, right? So based on these two tables, if I give you a table and you find it to be exponential, could you write the exponential equation?
Yeah.
Yes. The first thing is, what did you notice? What's the first number?
625.
Why is it 625? It's the 0. Your A value is your 0 value. Okay. And then what was your parenthesis value?
45.
It's 0.8. Why is it 0.8? It's your common ratio, right?
Yes.
And when we did 500 divided by 625, we got 0.8.
Wait.
You did 625 divided by 500. Switch it.
Oh.
It's y2 divided by y1. See the difference?
But you always divide by.
It's the second number divided by the first number. Okay. All right. How do we feel so far about a simple exponential? Good? Yeah. All right. Now, it wouldn't be math if there wasn't a little hiccup, right? It wouldn't be a regular day in math. Now, what if I have an exponential in the form of y equals abx plus d?
Uh-oh.
Plus d. Dun, 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 dun.
I don't know what.
Okay. And what happens is that property no longer works. Okay. So a table could be exponential with the plus d, with a transformation. Okay. And what we have to do is we have to first find the common difference and then the common ratio. So that plus 6 adds an additional step. So for example, the first thing we have to do is find the difference. And then we have to find the ratio. Okay. So it's a combination of both. All right. So you have to find, and that's because we talked about exponential has a linear common ratio. Y'all remember us writing that on our little explanation about linear equation, about linears and quadratics and exponentials, our Freyer models, that's what they're called. The very first set of notes we kind of took, right? It was one of the properties of exponentials, okay? And so there is a tie to being a linear, especially when you are kind of written in a linear form. So this plus 6 changes the fact that we find the first difference, then the second ratio, okay? So it's the first difference, then the second ratio.
All right, let's subtract by 6.
Okay? So let's see what happens. Ready?
Yes.
So if we plugged in 2 to this, what's 2 squared?
4.
What's 4 plus 6?
10.
10. What is 2 to the third? 8. 8 plus 6 is, you were just ahead of us, Paul. It's cool. 14. All right, 2 to the fourth? 16. And 16 plus 6 is? And then 2 to the fifth? 16 times 2 is what? 32. 32 plus 6 is? Okay. And then 32 times 2 is? Because we've already multiplied it 5 times. We're just adding one more 2 on, right? Which makes it 64. So 2 to the 6 is 64. Does that make sense? And it's 60, and that gives us 70.
And then you just do the normal stuff after.
So now but the first thing we have to do here, because of the plus 6, we have to do what? Find the difference, right? So you got to find the first difference. So 10 minus 8 is 2. 14 minus 10 is
4.
22 minus 14 is
8.
38 minus 22 is,
16.
and then 70 minus 38 is
32. That's a pattern.
OMG.
Doubling.
What is our common ratio? It's times 2. Do we see it? Okay.
Yeah, I see. We're so smart.
Okay. Yeah. So if I had a table like this and I notice that the first difference is not the same, that eliminates it from being linear, right? Does that make sense? So the
Yeah.
first difference was not the same, so it's not linear. And then if the second difference isn't the same, that means it's not quadratic. So what will be the last thing I test for? Exponential, which means that it's a common ratio instead of a common difference. Got it? All right, I want y'all to practice really quick on 11, and you should have the bottom ones. So 11, 12, and 13. All right, so really quick on here. Hopefully you guys are gonna kind of tell me really quick what the numbers are. Ready? What do we get for 1? What do we get for 2?
13.
What do we get for 3?
49.
What do we get for 4?
57.
7.
91.
Okay, and then we did our common difference, right?
Yes.
And what was our common difference? 4, 12, 36. And then our common ratio. And our common ratio was 3.
Miss, you forget the one.
I skipped something in this process.
Yeah, the first one.
Oh, fudgesicles.
That's 4.
I went down the wrong way. I'm trying to beat the bell. The bell's about to ring.
Hey, man, you keep doing that on the phone.
No, you're not. I don't want the bell to ring on us. Oh, 12, 36. Ha ha ha. Where was I at? 4, 12, 36.
Are we trying to? No, these are-
Those are your notes. You're gonna need them for your quiz. 108. And then, no, you keep your notes for your quiz tomorrow. 3:30.
It is pretty easy.
It is 3:30.
There we go. Yes, we are going to third period. All right, so really quick, I need to do the summary. I'm gonna just tell you that your common ratio is your B value, right? Did we understand that? The ratio is your B value. And when it's in this form, your 0 equals your A plus your D. Okay? All right. Thank you guys.